Oh, you are streaming directly from the Zoom. It's cool.
Yes, I think this is the most efficient way to do this streaming. Essentially, what we found is kind of when we do like broadcast, it's easier for us to have this control because it gives you the control as well on your machine. So I think you can use like open source software from Twitch to do broadcast. But sometimes like sharing screen and making sure that it works nicely without technical difficulties, best
Yeah.
option is to use Zoom. So I think we're live now. We already have 7 people listening to what discussing about Zoom and Twitch. So welcome everyone to our weekly live stream on Twitch. I'm excited today to talk about machine learning and Hazelcast, especially with its special guest today, Mohammed Koz, who kindly joined us today to discuss online feature stores with Hazelcast. So welcome, Mohammed. How are you today?
Yeah, thanks, Soaz. I am really fine. And I am really happy to join this Twitch stream. I guess we are nearly planning this session for 2 months, right? You
Yes.
couldn't find any chance.
Yeah, I mean, like we started like I think like late November, early December, but
Yeah.
it was like, busy from my side, busy from your side. So I'm excited to finally get it done. So especially with this topic, I think this is very valuable for our community to know what you can do with Hazelcast. So perhaps before we start and jump to the topic, maybe like a little introduction about you. What do you do at Hazelcast? How did you come to know about Hazelcast? And what you do
Yeah.
outside Hazelcast?
Yeah, of course. I can introduce myself shortly. I am Mehmet. I live in Ankara, Turkey. I am a undergraduate student at Middle East Technical University, basically. I am a senior student and I have one more left semester. I hope this year I will graduate. And last summer I joined Hazelcast as intern at the client team. And I am continued to work as part-time software engineer. And I am mostly working on the Go client and the Python client, but for the last 2 months, I worked on the feature store integration for our Python client. So other than the work, I am mostly interested in the photography and the Photoshop. I am really like taking shots outside of the Ankara and in the Turkey. So this is basically me.
Yeah, that's great. I think we need to create, because someone mentioned this to me as well. We need to create a Slack channel for photography. I think like so many do photography
I
outside.
know there is one channel for the photography. I guess I am in. You can join.
Okay, maybe you send me an invite then.
Yeah, of course.
Yeah. So that's great to hear. I think just before jumping to the topic, so because now I can see people are joining, so I'm really excited today to announce our first community event. So I'm sharing my screen now. So this is basically in real-time stream processing and conference event, and it's good news. We've been trying to put one conference, one event for our community, and we managed to do so now. The date will be 9th of March. It will be in person, so you can join us if you're in London or in the UK. And at the same time, it will be virtual as well. So the link, as you can see it here, you can sign up. Basically, you just put your details in here, and we will send you an email about the conference. So we will have a schedule, which start by kind of like optional workshop and training about Hazelcast real-time stream processing, as well as the Veridian cloud. And then we move to the actual topic. It's kind of like roundtable community discussion about real-time stream processing. So I'm really excited about this event. So I would like to ask you if you're interested as a community to join us and sign up using this. Of course, we will send more information about it in the coming weeks. But I thought that it's just like to make sure that I announce it here today, first time on Twitch, so everyone can join. So with that being said, I will stop my sharing my screen, and it's over to you, Mohammed.
Yeah, thanks, Soas. Let me share my screen. You see my screen, right?
Yes.
Okay. Hi everyone. Today I will talk about using Hazelcast as online feature store in your ML pipelines. And 1 minute, let me correct the view. Okay, right. The outline is basically I will start with what is feature store, and then I will mention about its advantages, but I don't want to spend much time on here because I will make a demo about how can you build a feature store using Feast and Hazelcast. We will interactively create an application using Django, and we will run a machine learning model in this demo. So most of my time will be on the demo, but I will shortly talk about the feature stores. And at the end, I will mention about the streaming thing. In the Feast, there is a support for the streaming data to the feature store. And we have a stream engine for the processing the data. It is Hazelcast Jet. And we are planning to implement integration for these two feature stores. And I will shortly talk about our plans. And then I will be done. So first, why we are developing feature store, because in our daily life we are using the real-time machine learnings in our daily routine. Basically most of our applications use some kind of algorithm for predicting our activity. For example, all of us are using banking applications and we are sending some activity to the bank, and based on these activities bank decides on our status and mark as the fraud activity. And other than that, all of us using Netflix and the YouTube, and we are watching some content, and based on our activity YouTube suggests or recommend us some videos. Also ChatGPT is very popular in these days, and it keeps the chat history and generates some reply based on your history. So all of these applications use real-time machine learning algorithms, and these algorithms requires real-time performance. Basically real-time performance means low latency in here, because these applications needs to retrieve the user information quickly and run the algorithm. They can't wait retrieving from a database. So this is where Hazelcast come in. We are providing a real-time infrastructure for running these algorithms with low latency. I will go into the details. So I said that developing this kind of applications is not easy because there are many parts. For example, machine learning engineers needs to work on that and develop a model. Also, the data engineering takes most of the time, and data should be manageable and processable. Also, deployment of these models is not easy, and this is where the ML ops come in. ML operations basically provides an general structure for handling these different parts, and feature store is one of the building blocks of the ML operations. Basically feature stores provides a interface or way for managing your data for the machine learning models. This diagram shows basically what is feature store, but first I want to emphasize that feature stores are not database or the streaming engine. They just provide a way to manage your data. You can see the parts in here. They generally have 3 parts: transformation, storage, and serving. And generally, there are some sources for the data sets. These are the where your raw data resides. For example, you can use a SQL database in here, and basically feature store connects to this database and provides you some API for generating dynamic and point in time or on-demand feature sets. They help you to achieve consistency between the training and serving data, because you have to manage these dataset creation, and you should be able to generate the dataset again. You cannot directly connect to the dataset database, because in this case you need to handle many things. You need to create the entities, the feature, group the features logically, and it requires much work. So you can use a feature store for managing your database instead of connecting it to directly. And as I mentioned, the feature store is not a database. It just provides an API, an interface for managing your data. It doesn't keep your data in own database. It provides a connection, and generally it separates the storage into two parts. One of them is online, the other one is the offline. Offline is used for the model training. It is generally a database or data lake, and it is where your raw data resides. Generally, it is much more bigger in size compared to online store. And it keeps the activity in the past, all the information of the system, all the training data, but online store only keeps the most valuable features, basically. By separating these online and offline store, model performance is improved drastically, because if you wouldn't have any online store, you need to search for your features in the database, and it is very costly, and basically it doesn't support real-time performance. So you are separating the raw data from the valuable features which you serve to the model and use in the inference phase. You are using an online store and having a low latency performance for prediction. There are many feature store available. The first option, as an enterprise, you can build your own feature store, but it is very costly, like I said. The second option is you can buy a feature store from an enterprise, or you can use an open source alternative. And this is where the Feast comes. Feast is an open source feature store, and it provides some features to the users so they can handle their machine learning model features. There are some concepts in the Feast. I will explain them in the demo, but Feast is like the diagram explained in here, only it doesn't support the transformation. And you can have both the stream sources and the batch sources. So as an open source project, we have implemented an integration to Feast for supporting to upload your online features to the Hazelcast cluster. And this is the general diagram for it. As I said, the offline store is generally a data lake or database, and you can use Hazelcast as online store in your Feast repository. And it provides an API to get the training or the inference data using these two functions. I will show them in the demo. So basically, suppose you have a large data set in a file. What you do is you connect this file to the Feast and you specify it as a file source. And suppose it has a timestamp column. The online store only keeps the most recent entries with the most recent timestamps. So they are used during the inference. So the benefits of using Hazelcast in this pipeline is Hazelcast provides a low latency, high throughput performance as a cache layer for the online store. But we have also multiple advantages. Firstly, Hazelcast has a stream processing engine. It is called Hazelcast Jet, and we have some plans to support Hazelcast Jet in this pipeline. So you can process your stream easily by a couple of SQL lines and have a real-time performance for your features. Also, it is very simple to run Hazelcast on both on your local for development and for the production. Also, we have a service, Hazelcast Viridian, and you can create a cluster in Hazelcast Viridian and connect to it without dealing with any technical stuff and upload your features to the Viridian. In this demo, I will connect to the local cluster. Let me switch to the codes. Basically, I have implemented a Django application for the demo, and we will have, yeah.
Is it possible, please, just to enlarge font size or increase font size, please?
Yeah, of course. Yeah, I guess it is better.
Yes, thank you.
Yeah, basically, I have implemented a Django application for the running the model, and I will run the model in the same runtime with the application. So I will not deploy any cloud. And in here we have our feature repository, but I will delete it and create it from scratch with you. This is the driver ranking module. In here is the Feast feature store. Let me delete it. So now we don't have any feature store in our applications. I will create a feature store using Feast init command. Let's switch to the. Yes, we can create a feature repo easily by running Feast init command. It creates the necessary files for us and provide a sample data. And I will use this sample data for the training the model. Yeah, it created a folder in here, and inside it, there is a feature repo folder. It is where our feature repo resides. And inside this folder, we can define multiple feature views. Feature views are just logical group of features belong to some entity, and entities are the like users or the point of the domain. For example, in this case, we will train a model for predicting the driver performance, and we will assign a driver to requested user. And in here, driver is an entity, and it has a driver ID. So by defining an entity, we can have a separate feature view which belong to an entity, and we can combine these feature views. As I said, feature views are just logical group of features for your machine learning pipeline. You can create different data sets from this feature view. You can join them based on some columns, and there are different type of sources and the feature views in the Feast, but today I will just use the simple feature view and the simple entity. Also, we will use file source for the offline store. You can simply create a file source like that, and Feast, as I said, provides a sample data for us. It is in here. Let me show you. We can simply open it. Yeah, it has some com rate and average daily trips for the drivers, and it is time step, as you see. There are many data in this file, not much, but many compared to online store storage. And we will use this data to train our model, basically. We can delete these parts. And it also provides a test workflow for testing the feast folder, but we can delete it. Okay. This feature store YAML files configure the online store, offline store, and all other options of the feast feature store. In here, to use Hazelcast as online store, we will change this online store section. And I have prepared the YAML file for the Hazelcast. Basically, currently you have to specify it like that, but it is because we didn't merge or work into the feast repository yet. When it is merged, you will simply write Hazelcast in here, and you will be able to connect Hazelcast cluster easily. Under that, you can specify the cluster name or the cluster member addresses. If you want to connect to Hazelcast Viridian, it is very simple. You will just need to specify the Hazelcast Viridian discovery token or other things like that. We will provide a documentation about connecting to Viridian with Feast soon. But currently we will just connect to our local cluster. So we need to run some cluster on the local. Let me open a cluster. You can simply start a cluster by Hazel start. And I want to start also the management center to show you the features when we transfer them to online store. So yes, they are running. Now we will have a feature view which combines different features from our file source. As you can see, we specified the source in here, and it points to the Parquet file in here. The fields are corresponding to the columns of the file. So when we run the feast apply, it will create the schema for this feature view in our online store. Let us see what it is gonna do when we execute the apply. Yeah, we should switch to the driver ranking and the feature store. Inside the feature repo, you can see the actions for the feast. When we run the feast apply, it will create an entity and the feature view, and it will deploy it to the online store. It will make many more actions, but for the online store perspective, it will create the schema for the driver horeless test feature view. Let us run the feast apply. Yeah, as you can see, we have connected to Hazelcast cluster and created a schema. We can see the created schema in the management center. Let me open it. Yeah, we see our cluster in here. In maps section, yes, we have a SQL mapping in here. We don't have any data because we didn't materialize our data to the online store, but we have created the schema for our feature view. Now our data only available in the offline store. We can get the historical data because historical data means we are creating a training data from the offline store. And we can train our model based on that. In here, for example, you can connect to your feature store using this function easily by specifying the path of the feature store. And you can call the get historical features, and it will create the pointing time joins and it will return a training data set to you. It is different than get online features because it uses all the data in the offline store. We are specifying the features for your model in here. We are retrieving all 3 features in this case, and we will simply train a linear regression model. It is not a complex one, but it will show the capability of the feature store. Let me run this file and train the model, and it will create a file for the model. Yes. Yeah. What is wrong in here? I'm checking. Yeah, basically, I received the same error previously, but let's skip the training part for now because we already have a trained model in here. It just gets the historical feature in here. Probably it is because of the path in receiving the data. But anyway, it just creates a linear regression model and fit the data to this linear regression model and save the model to this file. We already have this file, so we can skip the training part and focus on the prediction. For the prediction, we have an endpoint in our Django application. We are just requesting available driver IDs, and based on these driver IDs, we will call the model prediction. In the prediction, Feast also provides the get online features function. And in this function, you are just sending the driver IDs you want to get for the online features. And it returns the most recent and the most valuable features for your application from the Hazelcast cluster. But we didn't upload our data to the Hazelcast cluster yet. For that, we need to call Feast materialized. And we can call it from here. Yeah, we are in the feature repo. We can call the materialize comment. Yeah, as you can see, we had 5 different entities, 5 different drivers, and we have uploaded all of the features to Hazelcast cluster by calling the Feast materialize incremental command. In here, we first connected to Hazelcast cluster, and then we uploaded the data to the Hazelcast. We can see it on the management center. As you can see, previously we had 0 entries in here, but now we have 15 entries and we can query it. Yeah, all of the features for our entities in here, they are serialized because Feast requires to serialize the features before transferring it to the online store. So we don't see any meaningful data in here. But when we try to retrieve the data from the online store using Feast API, using this get online features function, it will deserialize the features and create the meaningful data from it. So now we can run our Django application from here using manage by run server. So now our application is running. We can open it. Yes, in here, we will provide some driver IDs to the model. And what it will do, it will open this endpoint when we send the data. And it will extract the driver IDs and then call the model.predict for predicting the most appropriate driver for us. In here, as you can see, when we send the driver IDs, it will call the get online features for these driver IDs, and it will generate a prediction for us. We can call for these three drivers first. Yes, as you can see, this data retrieved from the Hazelcast cluster, because I am retrieving it in here. Yes, df.toHTML is this table, basically. And we are retrieving this df from the model predict, and it retrieves it from the getOnlineFeatures function. So these features are the features we kept in online store. We store these features in Hazelcast cluster. And when user request, we retrieve these features in low latency and execute our model using these data. We can try different combination in here, but since we don't have any streaming data, or we don't change our data over time, all of the predictions will not change for the driver IDs. In here, we are just experimenting a real-time machine learning model running in the same runtime with the Django application. So in a production environment, you need to deploy this model to a cloud environment, and you need to communicate with it through a REST API probably. But in here, we are communicating with the model directly without dealing with any deployment. And we are just using both the offline store data and the online store data. So we can return to our flight, basically. Yes, let me back to the slides. Yeah, when we run the materialize request from the demo, it specified the features which has the most recent time steps, and it transferred this data to Hazelcast cluster. So when users wants to generate a prediction without searching for the features in the database or the data lake, the application directly retrieved this data from the Hazelcast cluster and performed in much low latency, basically. Yeah, in the last part, I want to shortly mention about the stream feature views and the Hazelcast Jet. In addition to this online store integration, we want to support the streaming features, because as you see, when you have a static data, you are just using the data from the offline store, and you are not using the power of streams. But basically, you can update the data in the online store in real time based on the user activity. For example, when user clicks on somewhere in the website, you can keep the statistic of it and update your feature store. And based on that, you can have a more appropriate in real-time predictions from your machine learning model. And Feast support it actually. Feast has a stream feature view class for defining dynamic feature views, and you can ingest data from your stream to these feature views. And since in most of time you want to transform the stream data, because stream data is mostly not very usable, you need to transform the data and have a more meaningful data. For example, you can collect the number of clicks on the website on specific parts. For that, you need to perform some kind of transformations over your data. And for that, we are planning to provide Hazelcast Jet pipelines. Using Hazelcast Jet, you can transform your raw data, your raw stream data, and you can create more meaningful features and transfer it to the Feast and store it in offline or online store, and use more real-time predictions from your model currently we are working on it, and hopefully we will release it in the February. And also we are working on a very exclusive blog post about this online store and the streaming feature views, and we will release it as blog post too. Basically, all the subject of mine is covered. If any question is there, I can answer.
Yeah, that's great to hear. Thanks very much, Mohammed. I think we got a couple of questions here. So someone is asking about difference between batch feature store and the online feature store. So can you comment on this one, please?
Yeah, basically batch sources are stores all of the big data set. When you define a batch source in the field, you are using this source for generating your training data, basically. Generally, when you have many entity or many features to use in your application, you are using only the most you are storing only most valuable features in your online store, because you don't use all the features you trained on the model while you are generating predictions. Storing all of these data in your online store is very costly and it is not efficient. It's equivalent to having a database, basically. For that, you are storing your most valuable data in the online store.
Yeah, I think this is very important, and especially when you connect it to Hazelcast. So the other question is, well, two questions. So first of all, is the code available online, and if it is possible to try it on Viridian?
Yeah, the code is currently not available to public, but Feast is already an open source project, so we will open a PR to the Feast repository, and when it is merged to the Feast, you can easily use it, and it will be able to connect to Viridian too.
Okay, that's great. So I think you also mentioned a blog post. So essentially, it's kind of like going through this demo basically with exact steps, because someone is asking how to repeat or duplicate this demo. So I would assume that's like a blog post, maybe like like you mentioned, will be like, you know, a step-by-step guide how to do it. Is that correct?
Yeah, actually, the blog post series will cover many more details because it will like 3 blog posts separately. We are working with Sandeep on that, but I can publish this demo on the GitHub after the session. I need to edit some of the parts, like the training part. It's failed, but I can share it. Yeah.
Yeah. So that's fine. I think like once we have this blog post out, if there is a link to the, so we're not rushing to it. It's just like making sure that community can have access to the actual demo and they can replicate it as well if they need to. So thanks very much for your time, Ahmad, today. It's been great to speak to you finally here. I'm already looking forward for the next step, so the streaming feature, so which is, I think it's quite a useful addition to this work. So thanks very much for your time. Just one
Thanks,
thing
Ross.
yeah, thank you. So just once again, I would like just to mention our community events, which will be on the 9th of March in London. So it will be hybrid event, which means if you are in London or in the UK, feel free to join and sign up in person. If you're not, feel free to join in like online or on Zoom, basically. So you have two options, and the idea of this conference is to get the community into one place where we share the Hazelcast development as well as the real-time trends for stream processing. Obviously, we will have a session for training. So this training essentially is just for the real-time stream processing, what you can do, what is required, and how basically you can do it on the cloud using the Hazelcast Viridian. Obviously, there are some kind of prerequisite to join, so you should be able, after you sign up here, to know exactly what you need in order to prepare for the demo. So I am already looking forward for you to join and sign up. So there is a form for this. And obviously, we will make future announcement about the events in the coming weeks. Don't forget to join as well our Slack community. We have a very active community on Slack for questions and answers. And I think there is a machine learning channel on the Slack community. Is that right, Mohammed?
Yeah, right. We are expecting all of the listeners.
Yeah, so expect some questions coming to your way on the community Slack.
Yeah, of
Thank you
course.
much, Mohammed. Thank you. Thanks, everyone. Bye-bye.